In this lecture, we're going to extend our discussion of scripting SQL to scripting SQL functions. And to put some context on that, let me remind you that you have already used, undoubtedly in your exploration of SQL to this point, some built-in functions. Let me show you a simple one. So you are probably aware that you can simply select without specifying a database or table. You can say select the current timestamp and just run that, and you get the time back. Okay, so you see that a function operates to, often it will take a parameter. This one doesn't take a parameter, or it may take multiple parameters, and it will return a value. And that value can then be used in whatever scripting you are doing. So we can do some scripting to create a function and then call that function from later parts of the script to do something with the values that it provides. In some cases, that might be to display them as field values, or we may be doing other logic and decisions on it. So it's time to start separating in your thinking the select clause and what you are displaying to your other SQL commands to what you are doing with it. Because a lot of the SQL that we've done up until now has been primarily to display the query result. Going forward, we'll continue to do that, and that'll probably be the lion's share of the work that we do. But occasionally, we're not interested in having a human being look at the results. We're making changes, doing updates, doing deletes, doing basic processing, and we aren't interested in the output of the affected results, but we may want to have another result, such as just the state of did it succeed, or a count of how many records were affected, or something else that we might return from that function. Okay, so a function differs from a basic stored procedure, which is like a subroutine, in that it's more like a programming function in that it takes 0, 1, or many input parameters, but typically speaking, a function is going to return a value. The value might be directly data that was obtained from the query, or it could be a characteristic or a number, a value that we want to use to make a decision or do some additional processing. Okay, so with that in mind, let's take a look at building a function. And to save time, I'll do a little cut and paste here. The function we're going to create is function discount price. And as we learned in previous lectures, the first thing we want to do is, in scripting, is make sure we clean up if the object already exists. So if the object is already out there, if it's not null, we're going to go ahead and drop it. So at this point, we know that anything we write, if this previous code has run, that the function no longer exists. Okay, and then let's work on developing the function that we want to have created. So what we'd like to do is we'd like to calculate a discount price. And let's do just a little bit of commentary here. So discount price is going to be equal to the item price minus the discount amount. And both item price and discount amount are fields in our table, and discount price is going to be a calculated field then, okay? And we're familiar with doing this. We usually do this way as an alias, and we say, well, we're going to select this as that. Okay, so let's go ahead and do that. Let's select, only we turn it around. We select this expression, that's what already exists there, and we do it as discount price. And then from whatever table we're working with, in this case, it's order items, and then any where clause we want to add. Let's start out with just this and see what that returns. Okay, so we've got the discount price. Just for grins, let's go ahead and so we can see the constituent elements. Let's also select item price and discount amount. All right, let's run that again. And so you can see this is our calculated field. And this is the native field item price, the native field discount price. And this is really the only value that we're interested in. And then we could have an additional where clause to filter to only, some of the records that we want to be involved. So far, so good. That's pretty straightforward. Now, how do we take this and turn it around so this can be used as a function? Well, one of the things we need to do is declare the function, and we also need to specify what the function returns. Okay, so having built this select query, we have a good handle on the logic. We're going to reuse that. Let me just go ahead and comment that out now, so it's clear that that's not the active code I'm working with. It's there for my development notes, if you like. And so what do I need to do to declare this function? Well, I need to create the function, give it a name, and let's go ahead and tighten this up so it's not taking up so much screen real estate. So we're going to create this function, and then let me bring it up so it's a lot more obvious that it takes as a parameter this value at item ID, and that's going to be an integer data type, and that it is going to return a money data type. And then we're going to begin the portion of the code, the block of code. So if I have a begin block, we also have to have what? An end block. So let's go ahead and put the end block out there now. So we're going to create this function with this parameter, and it's going to return a data type of money. And we begin, and we're going to declare the discount price parameter as money. And then let's take a look at our select statement. Using that as a model, we can say we're going to select at discount price and set that equal to item price minus discount amount. And then this is very much like a conventional query. So there's a from and there's a where. And where we're going to get that from, or from what table we're going to get that, is going to be order items. And again, we're working on the My Guitar Shop database. So from order items, and here's our where clause, where the item ID, so we're using the primary key, so it's only going to return one, right? Equals at item ID. So every time this function is called, it's going to return the corresponding calculated field of the discounted price for that particular record. Okay, so much is clear. Now, what we need to do before we end this is we actually need to specify the return. This is where the program will return the value that it obtained. It's obtained this value and it's put it into the discount price parameter, discount price variable. So return at discount price, and then it ends. Great. So to summarize our script so far, we use the database we intend to use. If the object already exists, we do a little cleanup. Once that cleanup has been completed, then, and we can now get rid of our notes here. We create the function that is going to return one value, the discount price calculated for one specific record as specified by the primary key of that record. And then we return it. Okay, that's all very good. So let's terminate that batch and go. We'll tell it to run that part of the code. And now we have the function built, if this all runs correctly, and then we can test the function. So let's go ahead and run this whole thing. Actually, I just highlight nothing if I want everything to run and see if it runs without error. Okay, so it said it was successful. How can I know that it really did what I wanted to do? Well, we're going to test the function in a minute. But if we come over here to the Object Explorer, refresh everything, take a look at my guitar shop, and we take a look at the programmability and list of functions. And let's see, do we have it here? Do we have it here? There it is. So that is a scalar valued function, and it's going to give us one value in return. That's why it's scalar valued. And it's the DBO is the owner. FN discount price, so function discount price. So now that it exists, and ordinarily I would save this script, preserve that. That's going to be what you use to build the environment, build out the application. So you would have a creation script for your tables and the schema, and then all of the objects on that schema. And you're starting to see you can build up, basically a script that builds your whole database and its business rules and environment. And that's what you want to do when you're creating applications. You can always go back and document it by, reverse engineering or pulling out the definition, script to, we come back to the function and script it out to to the clipboard or to a file or to the query window. But the point is, these now have been run. I can get rid of them. You should save them to include into your documentation. So for demonstration purposes, I'm just getting rid of all that. And now we need to try testing this function. So here's a little query that will exercise that. And let's see how it works. Select item ID, item price, discount amount. So these are just regular fields from the order items table. But this fourth piece, this is where we call that function to get that one value for that particular record. Okay, so let's put that on the same line. It really doesn't need to be on a different line there. I just had that there for emphasis. And let's see if this runs. And yeah, so this function was called one time for each record primary key that was encountered as it in the result. And you can take a look at the query execution plan and see that that is the case, and see if there's a way to tune that up or tune for a little higher efficiency. But basically, in terms of correctness of logic, that is working. Our function is doing what we intended it to do, and the value is generated correctly. So again, for completeness of testing, you should probably generate not only a success test, but a failure test. You could send it an illegal value and see what that does, or whatever other testing in your testing plan is appropriate, so that you come up with code that is not only correct and can deliver the correct answer, but is robust under failure conditions and fails gracefully and with appropriate traps for the error handling. So try catch kind of structure, catch all the exceptions rather than letting them be handled by the default error handling. So there you go. Onward to even more sophisticated scripting in our continuing video.